Hello again. This is an extension of the video on VLANs. We're going to talk about routing now, or inter VLAN routing mostly. So still playing down in this bottom left part of our screen there. We're going to just be configuring router 1. We will add a bit of routing later on, because if you've done RIP already, we're going to add that in. If you haven't, then review it. But what we want to do is to allow VLAN 22 to actually connect to VLAN 33, to be able to ping them. And that sounds a little bit daft. Why VLAN if we want VLAN 22 to connect to VLAN 33? Well, we're breaking up broadcast domains with our router, that's one reason. But you can control security through your layer 3 device. So you can put firewall rules on your layer 3 device. We're using a router as our layer 3 device at the moment. We'll have another video where we do inter VLAN routing with a layer 3 switch, which is normally the way you do it in production environments. So you would exchange this switch down here, this distribution or core switch, and turn it into a layer 3 switch, or not turn it into, actually have it running as a layer 3 switch. So a 3560 or something like that model, and it'll do the inter VLAN routing and access control lists and those sorts of things on that switch. But for now, router 1 is what we're going to do our stuff with. Now, what we built back here is we set up this distribution switch with trunks running all through. So that line running from switch to router is a trunk link as far as this switch is concerned. And at the moment, this interface on router 1 is just turned on, doesn't have an IP address on it, and what we're asking it to do is actually to accept tagged traffic, separate them to different networks, and then route based on that information. So at the moment, as it's configured, we can't do that. One option for us is to not have this as a trunk link. If we'd actually set this connection up as VLAN 22 on this switch and plugged it straight into the router, which had the correct IP address, so 192.168.10.1 in a /26 environment, and plugged it into the physical interface, that would be fine. We could then plug another cable into the switch for VLAN 33, so plug it into VLAN 33 on this switch, plug it into another interface on our router, and again correct IP addressing scheme, so 192.168.10.65 with a /26, and everything will be fine. The only downside with that is generally routers, and let's have a look at the physical one here. This one has only 2 ports, physical ports in it. If you were to get a 2911, have 3 ports, that's fine. Or you can buy an expansion card, a WIC 8A, no, not the color, 4ESW, you can buy extra ports. So it's going to cost more to get extra ports shoved on here. So what we tend to do, or what we would like to do, is actually do a thing called router on a stick. And that's setting up this as a trunk, which we have already. And we're going to actually create sub-interfaces on this gigabit 00. And with each sub-interface, we will assign them to the correct VLANs, put the correct IP address on them, and therefore get inter VLAN routing from that. So let's hop on and do that. So we'll go into our router, we'll go into our CLI. I was just playing around before. There's our routing table at the moment, so if you were running RIP before, that's pretty close. One thing you'll notice is we don't have a 192.168.10 any network in there, but that's okay, we can live with that. Okay, so let's hop in and do this. So configure terminal, and we're going to go on to the interface gigabit 00. Hit enter there, and all we do is put no shut or no shutdown. That's all you do on the actual parent interface. Exit that. You don't have to, but it's nice form. Then we go into interface gigabit 00 and we create a sub interface. Now I've just put a dot 22. I've created a new kind of interface and it's a sub interface. That number there is going to be, or this sub interface is going to have VLAN 22 information come through it. But that number there has got absolutely no correlation apart from being a nice read to the actual layer 2 information. It's just a number that's given it. We can have called it 555 for all we care. It does not have that layer 2 correlation with the VLAN tagging. Okay, once we've created this sub interface, we then need to go and type in an encapsulation and .1q. Now, I don't know if you remember back when we were looking at show interfaces trunk. I'll just go back into our switch just to remind us. And of course, we need to change that duration name. So if we show interfaces trunk, and the encapsulation for trunking here is 802.1q. So this is the standard trunking that we're using. If we go back to our router, we need to encapsulate each sub interface in .1q, and then it's asking us for our IEEE, so the Institute of Electrical and Electronic Engineers have come up with the standard to say which VLAN we're going to add to that. And this is where we're actually allocating the VLAN. We're saying that VLAN or tagged VLAN 22 traffic will come into this interface. We then need to put an IP address onto this. So 192.168.10.1. 192 is our IP address. Now we don't have to put no shutdown because our parent is not shut down, and our parent can't have an IP address either. So interface gigabit 00 won't have an IP address. Our interface .1q sub interface, sorry, gigabit 00.122 will have an IP address. So let's just have a look at that in our running config. So do show running config. Let's have a look at it. So there's our parent interface. Everything good. No IP address, and it's up. We've added the no shutdown command to it. And this is our sub interface. So we've created the sub interface by tagging on that .22. We've then said the encapsulation is going to use 802.1q as the encapsulation method, and we're going to allocate VLAN 22 to this sub interface, and we put the IP address on. So good. Let's do that again. So we can exit that. So interface gigabit 0/0.33 will create another sub interface on this parent interface. We're going to put the encapsulation as .1q, and we're going to allocate VLAN 33 to this. The IP address we're putting in here comes from our planning, and it's going to be part of this network, so it's going to be .65, and oops, there's our subnet mask. So for these two VLANs, VLAN 22 and VLAN 33, they now have an interface to play with. We'll need to create one more. So interface G0/0.44 for our management. Now this one's slightly different. The encapsulation is going to be .1q, and we're going to allocate it to 44, but also native traffic is going to come in here as well, isn't it? If you don't do this on physical gear, it really doesn't like you. It won't work. So you have to allocate the native traffic. You still, across each trunk, you still have to have native traffic defined and being the same VLAN at both ends. And we need to do that on the router as well. So the IP address we're adding in here is going to be 129, our default gateway for our switches. And that's it. So let's just have a look at our running config all over. So show running config. Let's scroll down. So again, interface gigabit 00 is just turned on. We've then created that sub-interface, .122.22, sorry. So 0/0.22, and we've said that belongs to VLAN 22. By encapsulation, it under 802.1q as the protocol. We've allocated that IP address and left it sitting there. We've done the same to another sub-interface, .33, and added it to that VLAN and put its address on. They belong to different networks, so remember your subnetting. The last one we've put in is our management VLAN, .44, and we put native traffic as the end on that because native traffic across our switches is running through VLAN 44. It's not tagged, still native, untagged, but there it is. So good. Let's show our routing table on this router just to see that they actually exist in there. And there it is, directly connected 10.0/26, directly connected 10.64/26, directly connected 10.128/26. So there's our sub interfaces. So it all exists in our routing table at the moment. So let's check if it actually works. Let's ping from 192.168.10.10 to 192.168.10.71. Let's just make sure our configuration is all correct. So 10.1 should be our sub interface. Let's just put our mouse over there, it'll show it as 10.1. And 10.65 for this one. So let's see if that works. So we'll go into simulation mode. We're going to get a few ARPs. We'll delete the previous one and we'll ping from there to there. And it's going to run ARP all over the place. So remember that's separate broadcast domains. So the ARP at the moment is to find our default gateway. And it's found that, so now we ping our default gateway. Our default gateway needs to find an ARP for the machine we're sending it to, so that ARP comes back and CDP is running. So let's just reset our simulation because ARP is now found across our network, and we'll just get our ICMP running. So our ICMP goes to our default gateway, and our default gateway comes back into our switches, tagged, untagged, and back into our switch, tagged again, still tagged, now retagged actually. So in our inbound, that SFD and these values here are going to be retagged, that TCI there, you can see it's changed, 21 over there, 16 over there, different tagging information for the VLAN numbers. So it's retagged onto a different VLAN because now we are running down VLAN 22 down the trunks, and then it gets untagged and back to our device there. So a successful router. So let's pop out of simulation mode there. So we've built router on a stick. Our inter-VLAN routing is working. We don't have any security across this network, so if you did want to secure VLAN 22 from VLAN 33, we'll need to add some port security. Not port security, sorry, some access control lists onto our router. So have a look for ACL video. One thing in this whole network, because I'm extending it as we go, at the moment RIP should be working, I think. Let's have a look. So show run. If you haven't watched the RIP video yet, hop in and have a look. There it is, so that's good. The network 192.168.10, that command there will take our 3 networks that we've suddenly created and ship them across our whole network. So let's just have a look at router 3's routing table and see if those networks have come in, and there they are. They're all in there. So RIP is working quite happily. Probably the same for ERGRP if we got that built onto here, and OSPF. But there's our 3 networks. These are our sub interfaces. We've subnetted this network. We've created a sub interface on this router to support those 3 networks through the trunks. Everything is working. Happy days. Well, good. Thank you for watching this video as well. We'll just kill that one and save that. And